There we are at the academic city university
Yes.
with your one and only host, Limbo Bimbo Sekore,
Yeah,
of the Voice of Zongo.
that's true.
I believe we're here today to meet one of the greatest minds we have in Ghana. I can tell you for a fact. Because I've heard so much about him.
Yeah.
I have seen videos of his creations and I think really enjoy your conversation.
In fact, let me cut you. What you are saying is very, very true. I also watched him on one of IBG Studios show, the Cindy show, yeah, and I really like him. That's why, out of curiosity, I wanted to meet him, and we are here. Oh,
Talking of the man himself.
yes, sir, yes, sir.
So
Thank you, sir. Thank you, sir.
so this is the man I'm telling you.
Yeah.
I just told you right now.
So, out of
Dauda
curiosity,
Mustafa.
out of curiosity, I'm here.
Yes.
I'm here, and thank you so much for bringing
Oh,
me
you're
here.
welcome. And I can tell you for a fact that you will enjoy your conversation. But
Sure.
I think you guys need to start it from this side.
Yes.
So I'm going to take my leave now. You and Dauda here. So me, they are there.
Thank you.
And then you just
So
okay.
I'm here finally. Voice of Zongo. We've met with the man himself. The man have been talking about on Voice of Zongo. Finally, we are here with him to discuss a lot about hardware engineering, hardware development. I mean, anything hardware. In fact, the camera you are even using, this man knows in and out of this kind of technology. So thank you, boss, for hosting us. Yes. And I hope you are going to take us inside to go and see what's going on. Muje, we should go to Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Voice of Zongo on IBG Studio. With me, Honorable Ufailu Sani, your host. In fact, there has been so many things that is going on around us in terms of technology. We've been seeing them, we've been using them, but I can tell you, most of us don't know how they are made or where they are made from. Today, I'm here in a laboratory with one great man who is behind most of these hardwares we've been seeing around and has knowledge about these hardwares that we know. He is Dauda Mustafa, the hardware engineer. I watched his video, about 45 minutes interview on one of our sister show on IBG Studio, and I really enjoyed the show. And I took it upon myself that I'm going to interview this great man, and I'm not going to do it in the studio. I'll come to his laboratory and watch what he has been doing. In fact, I have him. In fact, it took me a very long time, some time to get him because he's been roaming in the country, trying to finish some project. And thankfully, today I'm here with him. I'll let him speak, introduce himself, and then we take it from there. We will enter his laboratory and look at the things he has invented and the things he's yet to invent, and the things that are even here currently working. And I can tell you, I can see a lot of things in the laboratory, and I'm going to share that with you. Yes, so let's come to Dauda Mustafa. Boss, Assalamu alaikum. MashaAllah. You know, I don't know, some of my viewers haven't watched you. I watch your show and I enjoyed the interview. So I just want you to introduce yourself and say something small about you to my viewers and listeners. Then we move and then go and show them what you have in your laboratory. In fact, today, curiosity brought me here. So I'm going to whet my appetite. Please introduce yourself. That's your camera over there.
My name is Dauda Mustafa. I am a hardware developer as well as an engineer. And you are welcome to the Technology and Entrepreneurship Center here at Academic City. And we have a makerspace where we build prototypes and also work on hardware projects. The space is for everyone, not only limited to engineers, right? So as you are here, I'll be glad to show you around and then you see what we've got here.
Wow, that's interesting. And as he said the space is for everyone. If you say everyone, what do you mean by everyone? I just want to know.
Good. So normally when people hear of makerspace or makespace or stuff that has to do with tinkering and making, they only think it's all for engineers because there are so many deep stuff going on. But a makerspace actually is a playground for everyone. So you can be an artist, you can be a musician. So you can see all around. People come here, paint, and then use some recycled materials to create artworks, right? You can be wherever you want to be, but then you can still learn to build stuff from your.
Oh, okay.
We forgot the African making, right? So making in Africa was actually championed by West Africans blacksmith, where people smelt the iron, they beat it up, form it into different shapes of knives, cutlasses, tools, and all of that. This is our olden culture. We've thrown that away.
That's true.
Right. So we are trying to repolish it up and then bring it back to life and add a little bit of modern technology to it.
Wow.
And that's what we do here.
That's very true. In fact, I'm really connecting with what you are saying because I quite remember when we were young, we used to use this tin milk tin to create cars. We do a whole lot of stuff. But in fact, growing up, we thought it's just one of those things. So we've thrown those talent away, thinking it is not, something relevant. But per what you are saying, it seems like we should go back and visit those activities and then add some kind of technology in it.
Oh, yes. Yeah. I think we don't have to throw them away, actually. Me, growing up, that was what I used to do. I used to go to Seconds, I would go to the e-waste site over there.
Yeah.
Gather all sort of components and tools and then try to make things and see how they work.
Wow.
Creativity and innovation actually is here in Africa. Mm-hmm. So I believe it was taken from Africa to Europe, mm-hmm. and then they redeveloped it and then brought it back to us.
That's true.
In the form of these fancy devices we use, mobile phones and all. Mm. But the birthplace of all this started here in Africa. So it's time we reimagine our thoughts and then go back to our roots and then see how all this will help us. If you study deep science, okay, mm-hmm. and you try to connect it to the origin of where we came from, or the origin of the world, you will get to realize that most of the things we have here in Africa, okay, are basically what works in our computers, mm-hmm. right? So if you heard of the Adinkra symbols, mm-hmm. the Adinkra codes actually came from Mali, right? These are the fundamentals of what our laptops and gadgets work on, zeros and ones.
Wow.
So I won't talk much about that, maybe a different time.
Yeah.
So all these are embedded here in Africa. Mm. So like you said, you're welcome to my lab, and I'm be glad to just walk you around and then show you some of the things we do.
Wow. Viewers, you heard this for yourselves. It looks like we are throwing away our talent, and we don't really know what we have until people like Dauda Mustafa teaches or tell us what they really are. So without wasting much time, I'm going to walk with him, or he's going to walk us through his studios and show us what he's really talking about. And remember, he said you don't have to be an engineer, a software hardware developer, or an engineer to come to Make Lab Studio. But you can come here if you're an artist. Even curiosity can bring you here to make sure you whet your appetite with the things you find here. So without much ado, let's get going.
Okay, so let's start from the very beginning of the door.
All right, so let's go. Let's go enjoy the show.
Yeah, this is a first device we installed. It's just a sensing device, right? We have this drums over there. Mm-hmm. Once you open or close it, it gives a sound to alert everyone who is here that
okay,
someone is actually coming. So how it works is that it's a wireless system. We call that IoT. So this is a sensor, mm-hmm. and then it has a control unit over there, and then a power unit. So when this senses any motion, it will send the signal to the second device over there, mm-hmm. to just ring the bell. So
and the bell look like a hand and the xylophone And then I think it scratches on it. What a wonderful innovation. So this is a sensor. And I can see it is covered with cardboard.
Yes.
So something,
So you see, we don't want it to look more cumbersome.
yeah.
We just want to make people understand that this is simplicity. And
Yes.
we did it here.
And it can be done.
It wasn't imported from anywhere else. So cardboard, you could just know that it's just a local innovation that was done in the lab, and then we put it there, and then it's working. You can hover your hand around that and see.
Okay. Wow.
So once it senses any movement, then it welcomes you into the space. Then you are now ready to explore.
Interesting. So immediately you open the door, you enter, you are entering into a hardware engineer lab. So definitely you have to welcome with a sensor that senses your movement and then alerts the people in the lab to know that somebody is entering. So can I bring my daughter to learn this?
Yes. Sometimes people get so busy that our attention is not on people here. These are the stuff that
draw your attention. That's true. It's very, very interesting. And this one can even ward off intruders when you have it as your alarm in the house or something like that. Wow, what an innovation.
Here, actually, we're hosting a hackathon for kids.
Okay.
Right? So, like I said, the space is not for only engineers. So people come in here and they want to learn things. We use cardboard to make rockets. Right? So these were made by kids under 6 years.
Wow.
5 years kids who came here. Some were trying to make rockets to fly to Venus. 5 went to Mercury and all of that. And they put in some water here and then
shoot it up. Wow. I think I saw this elsewhere where the vapor or something
comes up.
Shoot the wow. So these were made by children. Oh, okay. So can I organize or any other individual or organization who is interested in bringing kids around to come and do things or maybe look what's going on? Can they bring them? Are they welcome?
Yes, we are welcome to everybody, like I said. So
okay.
We have schools who already know of us, and they come on periodic basis with kids to come and learn creativity, making, and all of that. In fact, some of the things you see here are made by some of those people who come here.
Oh, okay. So this is a canvas with some.
Made by, is it a 3-year-old or something like that?
Wow.
So he basically melted. We have some recycled plastics, right? So we are racing to become the cleanest city on campus in Ghana. So we recycle all the waste we generate. We spoke about recycling, what people can use plastic to make, and this was what he also did.
Okay, so I can see some melted plastic rub on the canvas. Give this wonderful abstract effect. Wow. That's wonderful.
And then here, this is actually a board here, right? So we put some, I think we have some, what do we call them? Some steel balls we normally put in there. And then we pull the trigger. So it passes all the way here. I mean, it's a scoring system.
Okay.
Yeah, and it's also automated. Once the steel ball gets here, just shoot it up. Then you control it over here with a mobile phone.
Oh,
so you just play everything here with a mobile phone, and then you score each other.
Wow.
It will be a little bit hard to understand if
the device is not fun.
Demonstrating that.
Wow.
But then we have some of the project profiles. We call this one Sustain City 2.0. It was actually led by myself and then students here on campus who were doing internship with us. So the task was to recycle plastics on campus into useful stuffs. And it was actually a big challenge. So we have to sit down and think of developing machines that will recycle the plastics and what we would seek to make. So we wanted to mix hard tech, into local manufacturing. So we developed machines that could turn the plastic into what we call filament. I'll show you when we get to the next slide. And we use those filaments in 3D printing. And I'll show you 3D printing too as well to create stuffs. And then the next one was to make what we call an injection molding machine. A small one. Industrial injection molding machines are very big and they cost so much in dollars. So we were making a very low cost version that will pick the plastic we have in the environment and then turn them into usable stuff like key holders, cups, bowls, buckets. I mean, small, small, simple stuff.
So the injection machine, if I understand, is simply a machine that takes the plastics and then melts them and then molds them. So you have made a small, the miniature version of wow. Wow. But let me ask a follow-up question. As the government or any authority knows about this kind of things?
Yeah, to some extent, some government officials comes in here and they see what we do.
They just enjoy and leave.
Yeah, so it's a channel of communication. Maybe they reach out to people higher in authority than me, but some of them come in here and then we sometimes want to form partnership, and most often we work with some non-governmental organizations because they are the people we are looking to work with more.
Okay.
And also attract funding because that's our main focus right now. Because with all that we do, it requires some bit of funding.
Yes,
So
of course.
we are open to governments, NGOs, or any entity that would want to partner with us to run programs or projects that relate to anything of their interest to us.
Wow.
Yes.
Wow.
Yeah, so these are also student projects. This is a heartbeat monitoring device. And that was the demonstration you can see over there. So normally here we assist the student build a project as well as work on community project.
Okay.
Right. So this is where they get to test all their knowledge. Right. So this is what the guy has built. That is an electronic heartbeat device.
Okay.
The stethoscope the doctors were.
Yeah.
They were invented a very long time.
Very long time ago.
So this guy was trying to reinvent it, add a bit of modification to make it more efficient and all. So he made this electronic.
So they don't use the stethoscope by using their ears, but the electric detector can check the sound and
display for you to see the figures and also everything.
Wow.
Yeah, for you to see how the heart radiance works.
Wow. Wow. This is very innovative.
So, like I was talking about the kids who come. So this is a WhatsApp emoji.
Okay, you see, I've been looking at the thing all this while trying to figure out. I can see that it's emoji smiling. Okay.
Out of the creativity of the other people, all these are also recycled plastics. All these ones. The person used bottle tops and then colored them and then created it. Also pasted it on over there. So the people who come in to come and learn some of this, at the end of the day, this is some of the things they do as starter and then.
That's very, very interesting. Very, very interesting.
So I think the next point should be over there. Yeah.
Let's follow up.
So this is another one.
So I can see this is also a plastic recycling.
Which was also made by one of the participants who comes in here who came in here to learn what we do. So we just allow them to apply the knowledge they've learned to create something.
Okay.
Yes. All these are bottle tops. These are made from pure water sachet.
Sachet.
Yes.
Wow. What an interesting work. Oh, interesting. This reminds me of a time where our chalwati, when it gets on, we use nails to patch where it. In fact, one unlucky day for me. In fact, this nail pierced through my chalwati and hurt me, and I can't forget. And in fact, this art remembered me as a vivid picture of what. And in fact, you look at one chalwati. Sometimes more than this, it wears off. Wow, wow. In fact, this art is very, very interesting. It has brought memory back, and I can see some Edinkra symbols. on. Wow. Cameraman, please capture this one very well for me. In fact, this art, I don't know how expensive it's going to be, but I'm not sure you are selling it either. Yeah, this one, man, it's very, very interesting. That's great. Wow. Wow.
So here in the digital fabrication lab,
Wow.
right? So I spoke about the classmates. Well, they do fabrication,
Yes.
right? So that's the traditional way of joining or fixing things together.
Mm-hmm.
Here is the digital fabrication. But what that means is that we use equipment like computers to control machines to fabricate what we want.
Mm.
So all these machines are called 3D printers.
In fact, I've never seen 3D printer in my life. This is my first time. I've been seeing it on TV, on the internet, working, but this is my first time seeing one. Probably being able to touch. I'm telling you the truth. My first time seeing one physical. Wow. That,
So basically, how they work is that you design what you want to do
mm-hmm,
on a computer, in a software.
mm-hmm.
Then we have another software that converts the design you made into a machine language that the 3D printer can
Can
understand.
understand.
Then you save that on a memory card.
Mm.
Set it inside the machine. Then
Machine work too.
the machine will print it. So once you do this, that's all. You are good to go wherever you are. Once it's done, then you come to pick it up.
Wow.
Yes.
I can see this. Can I pick it up?
I didn't even notice all that.
This is a mausoleum. If I saw it, I knew this is our mausoleum. Wow. So this is a 3D printer that print it. Wow. I hope you can see this. This is very, very interesting and made in Ghana in Make Love with Mustafa, Mustafa Dauda. A Ghanaian, a Ghanaian, a Ghanaian. Trust me, you will love this. I wish you are here in the studio with me. So this is what Voice of Zongo can bring to you, trying to show and elevate people like Dauda Mustafa, for you to know that yes, we have people in Ghana here who can do amazing things, but they are just under the ground, quiet until we, Voice of Zongo, fish them out. In fact, I'm highly impressed. Please take us through.
Machine is called a laser cutting machine.
Oh, okay, don't let me cut you. This machine designed the box we met there, the one with. Wow.
This was what was used to cut all those parts.
Mm.
This laser beam, right? And then it focuses through the lenses that are here.
Mm-hmm.
Cut shapes,
Wow.
and then we can also engrave on materials like wood, cardboard, acrylic. You can see some of them.
Mm. Wow.
So those who don't know what lasers are, when we were kids, we used to have this. There was this light,
Lights.
red light. When you press it, it goes very far.
Very far.
Yes, so that's a laser.
Mm.
So it's a very soft laser. It doesn't cause any harm. But this one uses what we call CO2 laser, carbon dioxide. You learn that in Olympics.
Yes.
It's reflected through some mirrors. It's focused down here. There are some lenses. It's also a digital fabrication tool. You design what you want to cut, the shape you want to cut in a computer. Then you use another software to convert that shape or that design into a readable format.
Okay.
You just send the command and then to cut the shape for you precisely.
Any shape
Any shape.
on any material, wood, plastic.
Yes, so there are two types of laser cutting machine.
Okay.
CO2 laser. No, there are a lot. But the most common ones are the CO2 laser cutters and then fiber laser cutters. For fiber laser cutters, you can cut up to metal.
Mm.
This is limited to metal. Yes, So most of the ones are using the labs and all of that.
Okay.
The COJ, fiber lasers, industrial kind of machines that cut metals, right? I think we have one there that we use in cutting machines, and I'll show you something that make with that.
Hmm.
Now, I was talking about 3D printer. So this one actually, my morning was very busy when you guys.
Yes.
So you can see an array of 3D printed type. You can put it.
Wow. So it look like you can cut gears
Oh yes.
and so it means any machine at all can be created here.
So actually, I'm building a machine. I just received these parts, which I ordered online. These are the individual components of the machine.
Wow. I can see some fan, heat conductor.
The news, but actually,
Yes.
this is a device that helps us in recycling the plastics. So, like I was saying, we develop some devices where we recycle plastics into filaments, right? So the filaments are the material that 3D printers use.
Okay.
Now they are very expensive, and we import them most of the time.
Okay.
We are trying to see how we recycle
Plastics.
to make filament. Building the machines ourselves. Now, this is so if you look at this is a filament made from plastic bottle.
Yes, and the color can tell it. Okay. Wow.
So we use that to create this, and we'll be using them in 3D printing. We use them to make board kits and all those stuff. It's a very cheap.
And it look durable. It feels durable. So can it be used as a filament? And that will. So if in the future we are using how do you call it, a 3D printer, this innovation or this invention will cut costs by not for us not buying the filament, yes, but we're using plastic. So recycling, wow, wow, wow.
I think we have a machine that does it. Over there, I'll show you. I'm making another one. That will be much more efficient for us to achieve a better process.
Wow.
Like I said, all these are 3D printed.
Yes.
All the parts you can see, the white part and all of that. So I'll be sitting here and then I'll assemble everything together to make the device. And when it's actually something I printed in pieces.
So how did you know these are the parts you need and then you print them in pieces? And how do you communicate with the computer to communicate to the 3D and then bring up these things? Because they look amazing and they look so complicated to me.
Yes. So for instance, if you want to make something, it starts with what you're thinking, what you want to make. Maybe let's assume you want to make a knife, right? And you start thinking, how does a knife look? How should a knife look like? Or what is it going to be? What is it going to be used for? Right? So these are the questions you ask yourself before you even start sketching something down. So all these were done through that process. So if I'm making a filament making machine, I'll start, okay, I need something to heat up the plastic for me to be able to form it in what I want, right? And after that, I need something to wind it, roll it. And that rolling mechanism, what should I use? So many thoughts. So you see a motor in part. So we ask ourselves questions, then we answer them by ourselves. That's a method of doing. So if you look at this, I wanted to wind it around. So you can see the original filament. That's the same thing over there. So, right? And how am I going to make that? And this look a bit different, okay? Because it's customizable. I can decide, depending on, because of what I want to do. It's not going to be exactly like this one. So I have to still ask questions. How am I going to do it to be able to work with the device I'm making? So at the end of the day, as engineers and makers, we ask so many questions about what we are going to do, right from the design, the thinking phase to design phase to prototyping, all the way to finishing, and even safety, right? So that's why most often we don't talk much because there is so much going on over there, right?
Means you have to be creative.
Yes, you have to be creative, one, and also you have to be very curious, okay, and also have the desire to learn. Yeah, that's the key things. Okay, so it's not like it just comes by magic. No, once you begin to ask yourself questions, fashion designers like this, the person will want an outfit to look like something, right? He will ask, okay, how do I want it to look like? On what occasion is the person going to wear it? Who do I want to? I mean, these are the questions the person's asks, and then before they will be able to bring up. Good. So,
I can see different types of 3D machines.
yes, that's a very good question.
Tell us what they do and why do you have so much.
Good. So let's start all the way from here. So these ones, okay, are the very basic 3D printers, right? They are cheaper. They are cheaper in cost and they are easy to work with, right? And basically, they are for small people who want to enter into the world of making. Okay, so that's that's why we had this from the initial stage. This is a bit more advanced. It's bigger and it's also very fast as compared to this. And also the 3D printing materials you see, they come in different types. Okay, we have PLA, which is the most basic one that every machine can use. We have PETG, which is stronger in some properties. We have ASA, and we have polycarbonate, we have carbon fiber. So these machines were made to be able to use tougher materials and also print faster.
So that means the PLA or the
PETG, yeah, the carbon fiber.
this cannot use them.
So this one can print PLA and PETG. It can print carbon fiber. And it can also print the bottle, the filament you are making, because it requires a high-end machine. So that's why we got this. And then that. This is the fastest one so far. Right? So this, yeah, so 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 this is not just an ordinary bolt. Okay. We use that to calibrate the printers. So calibration means that we set the parameters of the printers to be able to work for us optimally, right? So when you bring the printer in, maybe dimensions, sometimes you give it dimensions and the dimensions it will print, the dimensions will have errors, small errors in dimensions. And we also have what we call cooling effects, right? As it is printing, it's cooling, it melts the filament.
Cools it at the same time.
Cools it at the same time, yes. So it deposits it layer on each other. So it reaches the final stage. So each of them has their cooling rate and all of that. And even the movement of the motors that works in all are calibrated using this cube. Yeah, so once you finish and you get the results, we can now interpret it. Now when you look at this, so when you look at this here and you look at here, there's difference. That means there's something wrong. So this is for you to know that the machine is actually cooling properly or not. Now when you turn it this way, now when you look closely, you will see that there are some strings moving from here to that. We call that stringing in 3D printing. So for that one, we'll let you know that there's something called retraction. So when the machine is moving from point A to B, it has to pull the filament back. Otherwise, it will drip inside the model. So how fast it does that will make you know that, will let you know that through the stringing. So if it's able to do it very quick, you won't see any string. Yeah, so, and then the top is what we call surface quality. So like this is the surface. If you want it to be smooth, so you can read that from here too as well. So these are not just toys or fancy stuff that we do. Normally people come and they be like, oh, let me take them home and give to children. They send them home, yeah. Yes, for calibration. Meant, yes. And this is also a side drawer that I made for this. Now it's done. So when it's done, you can just pick it up and then you can now look at it very well.
Today on Voice of Zongo, I am done printing with
we call that benchy.
benching.
Yes,
Oh,
that's the
okay.
things we use.
The term sounds exactly explanation. Oh, okay.
Yes. Yeah, so these are a little bit advanced
So if
printers.
you go elsewhere and you see machine, 3D machine printing toys like this, they are not just toys. They are actually calibrating, trying to make sure the machine is well set up for a different project, something that requires a lot of measurement and wow.
So this is also a drawer which I printed to keep my tools.
You know, I wanted to ask.
Yes. So that's a side drawer. Yeah.
For tools.
Yes, for tools.
So these pen drives, are they slots to the machine or the machine is communicate directly from the computer?
So this one has a capability to communicate directly via internet connection. But you can also print offline using the pen drive. So you just slot it in there, right? So once you slot in, then you come in here, USB drive. So these are the files and the USB drive. Yeah, so you can scroll down. So these are the files. So this particular lamp is what is over there.
Okay.
Yeah.
Okay. So viewers, as you can see this lamp, that is the soft copy of
The lamp over
the lamp over there. So the 3D machine printed this lamp.
Yes.
And I want you to tell my viewers,
Yes.
definitely somebody would want to have this lamp because as we are being my producer is interested in it already.
Yes.
Yes, and I don't know if he's going to get it. So if people like him who are interested in things like this, where do they go? How should they go? Are they for sale?
Yes, so you just go to banksim3d.com.
Sim.
Yes, 3d.com. Yeah, and you just,
Sim.
yeah,
Yes,
you can make all the stuff on this as well.
so viewers, you can see the only thing we bring you on VOZ is quality and better. Something unique, something you have never seen before.
Now, these are another branch of 3D printers, right? So we call them process. Yes,
This one has 7 handles.
yes, two handles. You can put two filament on it at the same time. Yes, yes. So they are very durable and they are very workaholic too as well. Yeah, they are far more advanced than these ones too.
So what is this challenge?
So this is a filament dry box. Now the materials, some of them are high. What do you call it? They absorb water from the environment. They absorb moisture. So like the way I've exposed this, it's absorb moisture. So over time, it degrades and starts to break easily. Example is one of them here. Let me see if I can get. Good. So you see this? So just turn to spaghetti. You get it? So that's PLA. And it is the material that absorbs the most, I mean, it absorbs moisture. And when that happens,
Then it can't work.
it can't work anymore. So the filament is wasted. So this is a whole full filament
Filament, that is getting spoiled.
that has just gone bad.
So if I may know, the whole bundle like this, is it expensive?
Yeah, so they cost from 350 all the way to 600 cedis per one. Yes, depending on the type and then the quality as well. So if
Machine
dries them,
help to protect it from this.
yes. So if you don't dry them regularly, they will get to this and then you waste money, right? And more to the point, when they are not dried very well, when you print, you don't get very good prints. The print becomes very rough and then the surfaces are very bad. Yeah, so now,
Did you say these ones are workaholics?
yes, you know, depending on, there are actually companies based in the Czech Republic, right? And they were actually engineered with durability in mind, right? So if you look at this one, okay, it only has one motor here, right? But this has two motors, right? And the design of this, it's way stronger than this one, right? So it's also when you come down here, the sorry, the materials used in this, okay, were actually high quality parts as compared to these ones, which were aluminum and all of that. So that's the reason why these ones are very durable. And also, they are open source equipment, which means that people can take the design, rebuild upon it, and make it much more better than how it used to be previously. Yes. So what's next? Now the last one here the last one here you see, right? This is actually made by me, right? This one, it's actually made by me. So it's a clone of the original of this one. So everything, I'm not yet done making it yet. I didn't want it to look exactly the same with the colors, that's the signature, company signature colors. So I changed my colors to ash and then white, right? So I'm not yet done with it, but it turns on and everything. Just left with some few finishing touches, and all these were 3D printed. The plastic parts and everything were 3D printed over here. Yes.
So these things you can buy them. Okay, I know you do this.
Yes. Yeah, some of the things are there. You need to buy them, and then yeah, you put them together.
So that means very soon, through you, we are going to get a cheap and a simple 3D machine.
Yes, very soon. No, it's even there. It's not even very soon. This is not the only design I make. There are some smaller versions that we make for kids and all of that, which are a few thousand cedis or so. Each of these machines are very costly, so we are trying to bring down the cost to get. I mean, yes. So this is my very first 3D printer I bought. I think this was in 2018 that I got this one. It was in 2018, so yeah, and it's been with me all that time to now. This is also another 3D printer, and it uses liquid. It's not like this one that uses this material. You pour resin in here. So you pour resin in here. There's a place that normally submerge itself down. Then it uses what we call UV light to cure the resin. So this thing just pulls the model out of the liquid. As if it's a sci-fi movie that you are watching. Yes.
That's why it is included.
Yes, so because of the UV. Yes.
This is very, very interesting.
So basically this is all about the digital fabrication.
I really like the studio, and I wish I can sit here the whole day to see what is going on. Viewers, I hope you are enjoying it. So let's go to the next phase of our show.
Yeah, so these are more bottles waiting to be recycled.
Okay, so before they can be turned to the filament,
Yeah, we turn it into. Yeah. So, like I said, it requires a lot of thinking. You would. We don't just pick the bottle and then throw it inside the machine.
The bottles are here, you just put them into
No.
the machine, it's melted and it gives you this.
So actually, I have a video of an explainer video of how we process this. Yeah, and it's on my pages as well. Yes.
Which pages are you on all the social media?
So we're on Facebook and Instagram.
Okay.
Yes, Facebook.
We need your TikTok too as well. And frequently showing us things you've been doing.
Yeah, that's fine. Yes, that's true.
If we can, our producer and manager can collaborate with you to be showing you some of your work, even some bits. Yeah, people will be watching you because people are interested in this.
It's true.
Myself,
It's true.
one of them. I'm just in the good number device.
It's true. It's true. Yeah, so here is the woodwork lab. Now, the first thing we'll talk about is the injection molding machine I was explaining. So with this one, you put in the plastic and then heat up this block. Then you pump it into a mold. Okay, so we have molds that we made here. So you pump it into the mold and then you get the item that you are making. But you don't just take the full plastic. So like I said, each of the manufacturing process has its own processes. So with this one, you shred the plastics. You don't cut them into the strips you were having.
Oh, okay.
Yeah, you use a machine to shred it.
Okay. These are bottle caps.
Yeah, these are bottle caps. So we use a machine. Now, the bottle caps, the plastic they were made from cannot be used in 3D printing.
Okay.
So we have to find a different way of recycling them. And that's where the injection molding comes in. The whole thing you are seeing, this is not part of the machine. This is a drill press. So this is the machine. So the drill press, we are just making the use of this mechanism of the drill press
To press.
to press the distance. You get it. So injection molding machines, industrial ones, have all these things embedded in them. But we were trying to find out a very simple solution that will help us go this way. So you put this in a drill press and then pump it down. Now, if you don't have a drill press, there's one that comes with a handle.
That's
You just pump it inside, right? Now, this one machine that we are making is also a laser engraving machine.
Okay.
Yeah, it also works like the big one out there, but it's a tabletop type. Now, when we are going to schools to, work with them, teach the kids and all of that, we can't pick that big one. So we need smaller ones like this that we can just dismantle them and go and fix them on site and then use them to work over there. So we are still on it. Yeah. And this is the control box for this injection molding machine. Yes. So these are good. Yeah, so this, so this is a shredder. Yeah, that's a plastic shredder. This one. So that's what we use in shredding this. Good. Now,
I think you made this here.
yeah, so like I was talking about the fiber laser cutting, we design all the parts individually and then we cut them with the fiber laser machine and then we assembled it. The only thing we bought was the motor. Everything was designed and made in.
You can do your own full machine.
Yes, fufu. Yeah, I see. Yeah, so that's the shredder and we build this, so actually the aim of the project was to create a business model around it, people who want to go into small scale plastic recycling. But you can reach out to us, we'll build a shredder for you, we'll make the small injection molding machine for you, and then give you molds in addition. So if you want to create like keychains, you want to create like flower pots, whatever thing you want to create, provided we can do the mold for you, you can just come and take the machines, go home, then start collecting plastic from the environment, and then that's a business you are running. Yes. Yeah. So
I can see one here on the table.
yeah, so this is another one we are working on for recycling the plastic bottles to the filament. So this one has two heads, right? At the same time, they work at the same time, and then so that makes the process faster. Now this is the original one we use currently. This is the first one. So this one, right? So this one was the one we did, and that's what we used to create the filament I showed you. All these parts are 3D printed.
I see that.
Yes, and this box was laser cut with the laser cutting machine there. So there are electronics embedded inside the control panel. Let me see if I can even turn this machine on. Yeah. Good. It's on, right? Good. Yeah, so this is the temperature control device. Now, you see it's moving, right? So first of all, there's the ribbons, the plastic ribbons you pay. You put them through here. Then you tie it on this. It will be rolling it. Good.
So are you trying to tell me that this one is a heating mechanism or heating device?
Touch it and see. Good. Yes, so yes, this is a heating element, actually. Please don't touch it. I was joking. Now, currently it's heating, and you can see it, the temperature keeps going high. You're supposed to heat up to about, yes, you're supposed to heat up to about 400 degrees. Right, so once it reaches 400 degrees, that's the temperature which is enough to melt the plastics. Then this one rolls.
So by the time you finish, you have a bundle of filaments.
Yes, on this one.
Doesn't it stack together since it is passing through heat and also wrapping it?
No, it doesn't stack together. It cools instantly when it comes out. Yes, it cools. And then there's a speed mechanism here. So you can slow it down, you can go higher. Yes. So that's the first version we made. And then these are the other versions we are making. This one, and then the other one I'm about to make too as well. This one has two heads. Filament at the same time. Yes, to help us speed up the process. Yes, so this can really get hot.
We are ones who wanted to use 3D machines. We get filament very easy.
Very easy to buy.
Cheaper.
Yes, and cheaper.
Using our recycle.
Yes. Good. So, yeah, so that's it. That's how this works. Now, basically, here we do a lot of woodwork, right? Some people will say carpentry. So we have our table saw. That's where we cut whatever wood we want to cut. And if we are making a project that requires we cutting wood, these tables like this were all made here. So that's it. And then we have some hand tools too as well. You know, all these are tools that we are familiar with.
Yes.
Yeah, but people usually don't get to use them and all of that. We have all of them here. We have safety stuffs too here. So once you come in, once you have an idea, or maybe I want to make a fufu making machine like we said, just come in with the idea. From here, by the time you leave, you'll be leaving with what? Your fufu making machine. Yes. So that's basically what we do here. Yes.
That's very, very interesting. I really enjoy coming to the studio. And in fact, right now, things are bugging me in the head. And I think I can forming everything out. But I'll surely come here and see Dauda Mustafa for bringing out my innovation. And I really, really appreciate and very, very proud of my man here, trust me. And this has been Voice of Zongo on IBG Studios with me, Honorable Ufailu Sani. Today, as I started and I told you, we are going to enjoy and curious whet our appetites on the innovations that are going on in town, currently updated. And we've been here with Dauda Mustafa, the hardware engineer, hardware developer, and has taking us through everything that we want to see. Thank you so much.
Yeah, so I came in here not I think about 3 years ago or so, but there were already some programs that were running, which I was waiting for them to finish before I begin to enroll what I wanted to. So maybe later in the year we'll start to bring in some stuff like hardware innovation bootcamp, yes, other technology bootcamps. So people, yes, agriculture. I forgot to show you one more thing. Myself, I work on an agriculture device over there. Yes. We have most of the tools, the equipment we make are over there. So when we came, actually, much is not done in innovation in the country. You get it? So just like the way you have this idea, there's no space you go to make it happen. So that's why I'm just trying to see how we just publish hardware development company. Just tell us the idea you have. We'll all brainstorm with you and then know what the best way you can bring that idea to life. And then from there, look, it will surprise you that the idea you have, we will design it and let you just see the physical thing on a computer, simulate it for you to see how it works before you even start to even buy components and things. So this should be simple to even do.
Something like
Yeah, this should be simple to even do. We'll fabricate everything here in the engineering workshop.
yeah.
Yeah, so I think once we are in touch, some of this
Definitely,
development, anything
definitely, we need to come back again for this because I am happy, I'm enjoying, but I'm not satisfied. So definitely, I know my viewers are not also satisfied. So we'll come here once again and then meet you, and then we'll go through and we'll enter
the engineering workshop.
engineering workshop to see more in there, what is in there, and also try to see if we can put my idea to test. And I know everybody who is watching also have some ideas in their mind. They should keep in touch, as you rightly said, and the website you gave, so that whatever idea you have, we can also bring it on board, and then the engineers will help you brainstorm and come and make it come to life. So the how to contact you once again is
Yeah, so if you need, you just go to Bansim 3D and on Instagram or Facebook, the website is there
okay.
www.bansim3d.com.
Vaccine3d.com.
Yes.
And anybody who also, and also, I know people need sponsorship, and I think you should look into the camera and tell your viewers that it's not only about innovation. Sometimes with some capital resources also goes into it. So anybody who wishes to sponsor can also come on board to sponsor.
Yeah, so to everyone watching this, we are open to any institution, any individual or organization who is willing to come into the Technology and Entrepreneurship Center here at Academic City to work with us on projects, most especially engineering or hardware development field, right? So our doors are all open for partnership and sponsorship. We are always here, and then we'll be looking forward to meet people to work with them. Yes.
Thank you so very much. And this has been Voice of Zongo on IBG Studios. And with me, Honorable Ufailu Sani, Shekwarere, and I'm here with Dauda Mustafa, the hardware engineer, hardware developer, and he has taken me through a lot. And in fact, my idea that I have in mind with regards to poultry farming, he's telling me that should be easy to do. So it means whatever thought, whatever idea you also have in mind can be easily done, bring to life. So don't hesitate to go and search for banksim.com, contact or get in touch with Dauda Mustafa. Trust me, every idea you have, you can collaborate and brainstorm together with engineers, hardware engineers who will bring your ideas to life without any doubt. Trust me, without you going through so much try and error. It's easy. The people are here to help you do the right thing at the right time with less cost. Trust me. Thank you so much. This has been Voice of Zongo with me, Honorable Ufailu Sani. We'll see you once again.